Here's another area where people get confused, and that's between correlation, excuse me, and chi-square. So in particular, it's a confusion between correlation and the test of independence, also called the contingency test. Now, I think the confusion comes in because correlation, you're asking a question about, what is it? Well, the word is in here, right? Correlation. So you're asking a question about relationships. And what does the chi-square test of independence do? It's asking a question about relationships. All right, so you see that there's some confusion there. All right, and in fact, it gets, especially confusing when you're doing simple correlation, bivariate correlation, when you only have two variables that you're correlating, x and y. That's because when you do a chi-square test of independence, you're also working with two variables. All right, so correlation and chi-square, they both look at relationships. Simple correlation is looking at two variables. Chi-square is also looking at two variables, hence the confusion. Now, the way to separate them is to understand that although they're both asking about relationships, they're doing it in different ways. They have different approaches. If we look at correlation, we're analyzing scores, right? So we have scores on X and scores on Y. Not only are we looking at scores, but X and Y are ungrouped variables, so we don't put them into categories. They're ungrouped, and those scores were measured on an interval or ratio scale of measurement or level of measurement, okay? So again, with correlation, you're looking at scores. Those scores have not been grouped into categories, and the scores have been measured on an interval or ratio level of measurement. If we look at chi-square, chi-square analyzes frequencies, and your variables, your two variables, are categorical. So variable A might have started off as an interval or ratio variable. So for example, we might take the temperature outside in degrees Fahrenheit. That would be interval data. And we might group the temperatures into categories like, very hot, hot, nice, cold, and very cold, or something like that. All right. So we have to make sure that each variable, A and B, or X and Y, doesn't matter. Each variable is, the scores or the numbers are grouped into distinct non-overlapping categories. And then we just count the number of people in each category combination. So in each cell, we have a frequency, the number of people or things that fall or fell into that category combination. All right, so both correlation and chi-square contingency test are going to tell us if, variable X is related to variable Y, but it does it in different ways. I always like to throw in these, nice, hopefully motivational messages like, you got this, keep calm, this isn't so bad, etc., etc.